Good afternoon, everyone. Welcome to the second installment on the mini school on mastering pandas. Again, we are very grateful to Binjamin for his Binjamin Barsch for offering this course. And last week we had a very interesting introduction over the overview of the basic functionalities of pandas, and today is starting getting a little bit more serious, with data wrangling, merging, joining, and time series analysis. So I'm pretty sure it will be another fascinating lecture like last week. So Binjamin, without further ado, you already started sharing your screen. You're welcome to start your lecture. Thank you very much.
Cool. Thank you, Prof. And welcome everyone back to the mini school focusing on mastering pandas. So I only have 2 slides today because I think it's important to get right into coding. So this is opening slide, and then a bit about mastery from George Leonard. Mastery is not a function of genius or talent. It is a function of time and intense focus applied to a particular field of knowledge or skill. So another little quote from George Leonard's book on mastery. Try and get it. I think it's free PDF as well. You can probably get it. It's really worth reading. All right, that's all I'm going to present from PowerPoint. We're going to get straight into coding. I don't actually need to stop sharing and stop my video. I don't actually need my video as well. Maybe just get my Spider open and then share my screen again. Screen 2 over there. All right, so hopefully everybody can see my Spider open. Can I get some thumbs up from people that are there? Okay, cool. So I can see everyone is there. So I kind of looked at some of the feedback that I got from the form that everybody, well, most people did last week. And so we are going to cover the topics as I planned. I'm just going to take a bit of a different approach and slow down on certain aspects because there are quite a few people that are new to pandas. And the first thing I'm going to look at is actually the GitHub repo, and just to allow anyone to actually ask questions, maybe after the mini school, you can actually go to if you go to the GitHub repo, so let me share the GitHub repo again. I'll put it on the chat. Give me a moment. It's on the chat. I have uploaded lecture 2 to the GitHub repo, and if you go to discussions, you can actually add a comment, add this, if you want to ask questions or have suggestions, you can add that here. Go to lecture 1, for example. You can add a comment, anything about lecture 1 you want to know about more, anything we covered. Similarly with lecture 2, and you can also start a new discussion or add something here. So this is just for post lecture, just to ask any questions or any comments. And again, all the notes for lecture 2 I have here. So you can, fork it. I saw quite like 4 people. I forked the 5th one from my other GitHub account. So 4 people have forked this, and you can also just copy and paste the data to your own account if you want to. So that's the, so that's, I did put the GitHub repo there, so you can have a look at it. All right, so that is that, and the discussions and form 2. So I'm going to also have a form 2 as well, just to get feedback from everyone, but I'm going to share that halfway through. I just want to first go over cover some content in this lecture 2, and then we can, and then I'll share that, then you can fill it in. All right, so what we're going to look at today is a review of lecture 1. What we covered, just quickly, we're going to look at pandas input and output functionality. I think we'll look at data wrangling, aggregation, merging, joining, concatenation, and how that all ties in. So that's the agenda for today. Just a few questions and comments I got from the feedback. Some students wanted to know, well, they were obviously new to Python, so how do you actually learn from these lectures and notes? So anything to do with coding, it is a practical skill. So you have to be, typing, you have to be actively engaging with, the tutorial lessons or lecture or whatever you want. So just watching isn't going to help. You have to actively code. So what I suggest is, even with these lessons, as I'm coding, you code on your side. You get the practice and the feel of the understanding behind how to code. Just by following somebody else, how they code, you learn in that way as well. So even if you watch the YouTube videos later, don't just watch it. What I'm doing or whatever anybody else is doing in tutorials, do the same thing. And then play around with various other aspects of the code. Maybe it's something that applies to you, right? So it's quite important. Again, if you want to, you should have a terminal open. You should have some Python IDE open with you, so you can practice a few things while I'm explaining the content, and you can try your own things out. If you want, you can use a browser option if you just want to play around. So I have a link here. This is probably the easiest to do if you just want to play around now with Pandas. It has Pandas built in, this link, trinket.io. So I'm going to play around with that. And then there's a few YouTube videos, this is all on GitHub. So you can look at these YouTube videos to how to install Anaconda. But again, if you're familiar with it, you can install Python and use various other ways to do it as well. Lastly, if you are new to Python, remember, well, there's a huge Python community around the world and in South Africa as well. So there's a Python conference usually around October time. So where people from around the country gather for a conference. Last year was in Durban. So I'm not sure what's going to be this year, but just take note of it. I'll put that in the chat as well. Yeah, just for those that aren't aware or I guess new to Python. There's a few questions about comparing R to Pandas as well, or Python in general. So there's a lot of articles online that you can look at and research and find comparison. I'm not going to spend too much time on that. Fair enough to say that pretty much everything you can do in R you can do in Python. There are certain like advanced stats and probability functions and libraries that are unique to R, which you might not find in Python, but you can probably find a way around that with Python. And if you aren't familiar with R, it's important to diversify your portfolio, put it that way. So if you know R, just learn Python. It'll benefit you in various ways, and it's always useful to learning a new language. Shows you new ways of looking at your own language, and maybe you learn more skills. Is the audio correctly? Is that anyone else have a problem with that? Can you hear me still? Anybody else have a problem with audio?
No, it's absolutely perfect.
Okay, all right. Okay, so let me carry on. Okay, so we're going to look at a review of lecture 1. And then there's certain aspects that I'll go into more depth, in this lecture. All right. So in lecture 1, we looked at the iris dataset, quite well-known dataset, and what we did was we read it in as using pandas, using a read CSV function, and in this case, I'm actually getting this from my GitHub repo. From lecture 1, I'm actually calling it from there. You can, read it from your own local folder, or if you want. But I'm actually reading it from GitHub repo. And then, as we did last week, we went to 3 aspects of like accessing specific columns, getting the values of the data, a little bit about chain commands, and the sign function. I'll speak more about that today, and some other aspects, that should be familiar to you if you are, if you know pandas. If not, this is probably quite new to you and might struggle. Right, so that's briefly what we went over last week, and today I'll go into a bit more depth into pandas functionality. So the first thing we're actually going to look at is input-output functionality of pandas. And the most important resource, if you really want to master pandas, is to look at the pandas documentation, right? So I have these 2 links here, so you can follow me if you want. I put them on the Zoom chat. And this really tells you what you can. So Sieni, the code in lecture 1, it's all on the GitHub repo. So I'll put the repo there again. So I just go to folder lecture 1, you can find it all there. Yeah, so I was copying this one over here. Let me just put that as well. So let me just bring this across. All right, so again, if you want to master pandas or any Python library or anything, you have to really look at the documentation. So these are 2 useful resources that describe the input and output functionality of pandas, right? So most cases, we're going to be working with the function called read CSV. All right, so read CSV is it's a very robust built-in function in Python. Well, in pandas stands for comma separated values, obviously for CSV, and it can also based on your delimiter, like if you have a tab or even a semicolon or other delimiters, you can actually specify that as well. So which is quite useful. So there's a lot of functionality, a lot of customization, for reading a CSV. Okay, I won't get into this just yet. I want to look at all the different types of files and data you can read in. So CSV, most popular one, and obviously there's input and output functionality. So what you can read, you can also write, right? So you can read CSV files, you can also write your own CSV file. You can read in text files, JSON file, HTML, LaTeX, XML. You can read an Excel file as well. I do a few examples, in the lecture today of reading in a CSV file and an Excel file. I do a HTF5 as well. And there's various other formats I'm not too familiar with. I do a SQL file as well, how to read a SQL file and also write to it, right? So these are the various formats of data that you can read and write to in pandas. Okay, so the first thing we're going to look at is a CSV file. So a lot of the feedback I got was, I have this kind of data set, what do I do? Or there's this, like, I have very, I want to modify the columns. I don't want to change certain fields. So if you actually have any specific request, probably can't cover it today, but go to the GitHub repo, go to discussions, and add a comment and say, like, I have this data. You can put the link, you can upload the data to it. And so I have this data, I want to do that to it, right? So I can, we can discuss it in next week's lecture, right? So if you have any data, any specific questions, you can just put it here, and then we can look at it next week. So give me a thumbs up if that is helpful. If not, then, you can just carry on listening. All right, so we were looking at a CSV file, right? So typically, I want to have a quick look at, okay, this was just all the different functions that you can use. And then this one was, yeah, so this one was just the basics of a CSV file, right? So typically you're going to be using a read CSV file, and it's made up of your file path, or you can have a file path on your local machine, or as I've shown you, as a URL as well. You can specify that. You can also specify the delimiter, as I said, and you can also specify the column names or the headers. So you would add a list, like we've done, which we did last week, specify the actual header names you want, because sometimes your data might not have, it might not have column names, so you can specify your column names as well. These aren't too important. There was one other feature I wanted to show you, which is quite useful, which is skip rows, and maybe sometimes skip in the initial space. But skip rows actually quite useful for a lot of data where you have a header, and the header might describe, you know, it might just be like comments or just text that isn't useful for the data. So skip rows is quite useful sometimes to actually, you know, if you want, if the first 10 lines is a header describing maybe the data and then who wrote it and when and whatnot, things that aren't actually useful to actually doing a, you know, processing the data, then you can use skip rows. You can specify a number of rows to read as well. So this comes in handy if you're working with large data. So we speak about, does someone want to zoom in? Sure, it's fine. So zoom in. So the one was skip rows, very useful parameter. It is, so these aren't, you don't actually need any of these function of these parameters. All you need is actually just read CSV and a file path. That's actually all you actually need. All of these are by default not used. So these are just actual parameters which I think are useful and you most likely will use. So again, skip rows is quite handy to know about n rows, number of rows of file to read, and reading large files as well. So we might touch on it next week, but that's big data. And how do you handle big data when you might have like millions of rows of data? How do you handle that, or multiple files, right? How do you handle that? So I'll chat about that a little bit later on. But you know, these are things you can, you know, Pandas has some tools to work with big data, but there are actually other libraries that it's specialized for. So there are limitations. And yeah, so this is some other parameters, skip blank lines and whatnot, which I won't go through too much. There's a lot of parameters, as you can see. I just try to mention, you know, the basics. If you are looking for something specific, you're gonna have to go through the documentation or just Google it, or even use ChatGPT if you really want to. So some of the data, I mean, just to kind of give you some perspective of some data that people have given me just to play around with. You know, this is geospatial data, and you can see, you know, this is not a typical CSV file because it's separated with semicolon, and you know, even the header file isn't sorted, you know, correctly. So this is typical data you can, you know, quite, you know, easily read with Pandas and sort it correctly. There's some other, okay, that one isn't too interesting. See this one, right? So somebody asked, well, commented in the feedback, you know, what happens if you have multiple variable data, like if you have data that different types. So I mean, really it's only this column that is quite unique. This was classified as more of a string data type, and how do you work with that? There are other ones, that other data types that might be more complex. like for this one, for example, working with various types of data types, you have strings and integers. I don't think the only floats here, but working with this type of data, you can get even various other data types like time and coordinates as well that you might need to work with. And I think this was also quite interesting. I think this was something to do with genomes. So how do you filter such data? I think somebody asked like to remove the brackets and the X's or something, right? Like how do you read this data in and maybe filter it or remove some of the delimiters and certain features? Like you just want to get certain aspects of the data. So how to do this in Pandas was something you obviously can do. Right, so that's just a few examples of data. If you have your own data, specific questions added to the discussions in GitHub, you can possibly still look at it today, but otherwise, you can always look at it next week. All right, so reading a CSV file, that's pretty much straightforward, and I've done a few examples. An example last week where here I specified the URL. There's no header, and this is another parameter. Names is a list that just has the names of all the columns that I want. All right, so this is just reading in a CSV file. You can also read in an Excel file as well. So there's an Excel file here that I created, which is the same as a CSV file. It's only one sheet. You can specify what sheets you want to read or how it will be read in. So it'll actually create multiple data frames using read Excel. It's only if you need it. And then this is just reading a text file, for example, with a delimiter as a tab space. So I think it was this one over here. Yes, this was with tabs, I think. So reading a text file, you can do that. So for SQL files, somebody did ask about SQL. So I work with Postgres databases. So here I just created a dummy database. So typically what you would need to do is you first need to connect to the you first have to connect to the database. So I'm assuming if you have Postgres or MySQL or something similar running on your machine, or even if you have a cloud-based database, you can connect to it too. But in this case, you would, because it's running locally, I'm using a Python library called scicop2, and I'm connecting, I have to create a connection status where I connect to the local host, the database. This is a database name and the very generic user and password. And now to read to a Pandas data frame, I just use a .read SQL function. I query what do I actually want to query for that database, and I'm just selecting all from the project. So the project is one of the table names. So there are a few table names. So that's just one of them. And you can specify any SQL query in Pandas, which is quite nice. If you're familiar with SQL, you can query anything you want, and you can read it and specify a certain data frame. So I can, before I run this, I just want to show the HDF file. So I didn't have HDF file, so I just created one. And here I'm actually showing you how to actually, how I created one with the data, and then I'm just reading it again into another data frame. So I haven't shown this anywhere else to create a CSV file, for example. I think this one would just be, where's this one? So for my CSV file, if I've read in a CSV file, but if I want to now write the CSV file, say reference my data frame, say dot, and I say 2. And you see all the different options you have to clipboard, to CSV, to dictionary, Excel, a whole bunch of options that you have. So I want to write to a CSV file, and then I just specify, dummy data .csv, and that's it. That'll write this the CSV file. Okay, and then so this is just two HDF files. So that creates the HDF file, and I'm just reading it. Okay, so if I run that, let's just see what we get. Okay, so look, if I look at my variable explorer, I can see this is my CSV file that we're familiar with. The HDF file, not much in there, but we're showing you how you can use it. My SQL file. So this is this is dummy data, but this is pretty much, there's only one row of data in there. Text file, the Excel file as well. This is only one sheet that was in there. And then so this was actually a query, the SQL query. And then this was the HDF file. So that was the just reading in different types of data and how you can do that. So there's a few questions there. How do I change my directory on Spider to where my files are stored? So what I suggest is you create a project, say a new project. So if you already have your folder with your files in there, just say existing directory, and you choose your folder where your data is. Right, then in your files, you actually see it. It'll show you a little s.spy project, and that has all your files and formats and how you structured your environment. It'll store this all in this .spy project. So that's the most the best way to work with files in a directory. Just note, if you are storing this on GitHub, to add SPY, the spy project, and you git ignore. You don't want to store this in GitHub. It's a lot of files. If you want to, you can, but I wouldn't recommend it. How do I change my directory on Spider? Okay, that's the same question. Is there a way to specify a path where to write the CSV file? Yes, you can. So where's my example? Yes, over here. So you can specify it, for example, where's my CSV file? Here we go. So you can specify that by adding, a file path for example, you can have a file path wherever your maybe if you have like this on a C drive, which usually like users, and then your username and folder, right? You're gonna have to use something like that. And then you would just do something like that, and you could say just file path and add it to your file name. So you can specify it like that. If you want to maybe specify it maybe to your local directory, maybe you want to put it in a new folder, for example, you can do something like, let me just leave that there and just copy it. So where was that example I had now? So I can do something like dot, and then new folder or something like that. If you want to store it in a folder, right? So there's various ways to do it. That just an example. Hope that answers your question, Wilco. Yes. Okay, so we're moving on now. Any questions or comments, can put it in the webinar chat, and I don't see nothing on the discussion. So again, you can put things on the discussion if you want. Okay, so now we're moving on to something a bit more complex. Well, not too complex, not there yet, but data wrangling, right? So, and aggregation. So it has a few, it's quite a broad topic. If you look at, the documentation on data wrangling, is quite involved in Pandas, and there's many things you can, many customization, many things you can do to your data, which we'll cover here. But, wrangling first, there's a few things you have to do before you actually even look at your data, which is, maybe cleaning it up. So wrangling, or mugging, or whatever you want to call it, you want to remove duplicates, sort out missing values, correct data types, converting the data formats, and then, merging and joining, right? So these are various things that you do before you, start processing it. So I have an example data set that I called med data. So if you look at med data over here, zoom over there. So it has index, duration, data, pulse, max pulse, and calories. So some these are users or people that have their record information that I'm using to explain the example of how you first clean up your data set. So if you look at what I notice here is that the index column is redundant. When you're reading in a data frame, it creates its own index. So this index column is going to become redundant when you read it in. There's some nan fields as well, which isn't too handy. So for example, there's a nan. It can be empty space as well. It doesn't necessarily have to be nan. There's a nan there as well. There's in row 26, the date is incorrect. So if you look at row 26 over here, so this is the format of the date, and this one is incorrect. So there could just be a typo, maybe somebody recorded it incorrectly. So it happens. The wrong format, duration of row 7 and 13, something about the wrong data. So 7, yeah, so this value is more of a, not really wrong, it's more of like an outlier. So duration, this refers to duration of how long a person would exercise for. So you can look at the trend, max is like 60. So 450 is probably just, input incorrectly. So something we can sort out, and, removing duplicates too. So there's a duplicate in row 11 and 12. So these are the same. So how to remove that? Leonard, so yes, look at the GitHub repo. All this again is on the GitHub repo. So there it is again. All right, so that was the, we're just first going to look at cleaning up the data a little bit. We're going to won't spend too much time on it because it should be, quite straightforward. So the first thing we're going to do is, okay, we've read in this data frame or the CSV file just using read CSV, and I'm just creating a copy of it. Can anybody tell me the difference between doing this and using the copy method? If you know Pandas well, you should be familiar with this as well. Yes, med equals copy, so something like that. The copy method, or what that does. So if anybody is familiar with it, please, you can let us know. Difference between using this and the copy method. Okay, so thank you, Johnson Lamini. This is for reference. Johnson, you can tell everyone you're commenting to the hosts and panelists, so you can just change your comment to everyone. only the host and panelists can see it. Okay, but in any case, we can quickly go through this. So now, how do we remove the index column? So if we look at the metadata, we can see, I guess actually not, that's the CSV file, but I actually want to look at the data frame I've read in. And the data frame is in the variable explorer and is called dfmed, right? So here's our data frame. And the first thing I'm going to do is I'm going to you can remove it by using drop. So if you can drop the index column, and then use this parameter called inPlaceTrue, which modifies the existing or the original data frame. And then axis 1 refers to the column. So anybody else would like to know the difference between what is axis 1 and axis 0? So please, you can, anyone that's familiar with pandas, what is the difference between axis 0 and axis 1? Okay. So while we're getting feedback from that, if you need to just remove any column, we can do that by just using drop and referencing the name of the column. So you can do that with any column. Just say drop the name of a column, inPlaceTrue as an axis equals 1. Cool. We got the answer. Axis 0 is for row. Axis 1 is for column. Cool. Thanks for that. Okay. Now, if we want to change the original data frame, that's for inPlaceTrue. I mentioned that, so that's why that's why we have it. Okay. So now there's a useful feature of which is full nans. So full NA is full nans, or this is for empty values that you can remove. So many times you might have data that is empty or has a nan, or you want to find a way to kind of remove it or maybe fill it with the appropriate value. So the one of the parameters is value to use to fill holes. Either 0 or something else. You can actually make it modifiable. You can specify the axis. 0 is obviously index, and then one is the columns, as we saw in the chat now, and other various ways. So definitely look at this documentation for other, how useful for NA works, right? So so once you remove the nans, but we don't necessarily have to remove it. We can replace it with a value that's more appropriate. So for example, if we look at the calories, I think I want to look at the copied one. Is it? I think I removed it there already. Mid. There we go. So in this one, you can see these are the calories, and there's few nans. So what I want to do is actually instead of making it 0, because that would bias the data, or removing the row, because then that would remove all the other information which might be useful. We can maybe just work out the mean of this column and just replace the nan with that mean. Right, something is very useful to do. So how do we do that? So we can go to go down here. So what we're going to do is we're going to first reference a column, and this is a type of aggregation. You can, for any column, you can specify the sum, the mean, standard deviation, the min, the max for any column. So what I'm doing is I'm creating a new data frame for that, and I'm filling it, well, I'm for that value, and I'm filling all the nans with that value, right? So if I run it, you'll see that the calories is now replaced with the median value. So there's no more nans in the calories, which is a very handy feature to use. Sometimes you have, as I said, the wrong date format. So you would have noticed that there is one of them was a wrong date format. I have to go back here again and say, was it this one? One of them was a wrong date format. This one over here, right? So it's also a NaN and so and a wrong date format. So you can decide what you want to do with this one. I mean, in this case, I just remove it or replace it with a specific date. But this one is a wrong date format, right? So how do you fix this date format? You can just replace it with the actual value. Or you can do is convert that specific column to the date time format, and this one is replace that with the actual value, and then with the NaN I just removed it. So the drop NA, as I showed it before, this is like we did with full NA. So you can also do drop NA where it'll drop any NaNs, so that one NaN value will just be removed. Quite important to note is that when you removing things, if you're moving a row, the index won't be modified, right? So if I just run that, let's go to med, you'll see, which one was it now? Oh, I said reset index already true, so let me just run that. Med. Can't remember which column it was now. Any case, but you have to do this to make sure that the column, to make sure the index is reset, so it counts from concurrently. So another thing to take note of is wrong data. So for example, that one value we saw was 450. I managed to just change it to 45. You can remove it if you want. This is really up to you and how you want to work with the data. And sometimes there is you want to filter the data. So if you have, for example, in the calories column, if you maybe want to filter the data, you want to, if the values over 350 are unrealistic for some reason, you can cap it, for example, to 350. So this runs through all the index values for the data frame, and then for that value, it'll check if it's bigger than 350, and then change it to 350. So if you can see those changes there. Okay, and for removing duplicates, you can do that as well, but just using drop duplicates. So there was row 11 and 12 had the duplicates. Okay, so there was the next section I want to quickly cover. I guess the start of this is grouping and aggregation. And again, if you click on the link, this is quite an in-depth function in Pandas, grouping, because by group by it actually has various other supplementary functions, which is aggregation, transformation, filtering, and various other things you can do with group by. So we're going to look at a few examples here, and then try and cover probably some more examples next week. Okay, so aggregation is a group by operation that reduces the dimension of the grouping object. So results is treated as a scalar value for each column in a group. And some of the aggregation functions of group by is like max, mean, any, min, quantile. So for example, if you look at, if you run this now and we're looking at Let's check where we are. Here, this is group aggregation. Let's run that. So what we did now with working with the iris data set again with the sepal length, like the flower length, width, and whatnot. We worked out the first one worked out the based on the class, and there were 3 classes, if you can remember from the data set. So there were 3 classes of species. So these were Setosa, Versicolor, and Virginica, the 3 classes of plants. So what I'm doing is working out the mean for that class. And then, and furthermore, if I just want to specify, sepal length and sepal width, I can, right? So the first one is just working out the mean based on the class for all of the columns, which you can see there. And the next one is just for these 2 columns, right? So I just want to specify that. There's also an aggregate method, which is quite similar to, you can either use aggregate method or just use a sum method here. Pretty much does the same thing. Another quite nice feature of group by is you can specify your own functions or multiple functions. So, for example, in this one, we can use aggregate. We can use sum, mean, and standard deviation. So if you go further down here, for each column, it works at the sum, mean, and standard deviation for these groups. If you can see that over there. So it's categorized into the column, but then in that column itself, it's aggregated into sum, mean, and standard deviation, same with flag and all the other ones, which is quite handy to use, and you can use other features as well. You can also apply your own function if you want. If you maybe want like square, or multiply the length of 2 columns together. You can use your own functions. Yeah, and this example was just to show you some other things you can do with aggregate, work at the mean and max, and whatnot. So this one, yeah, that was just aggregate. Apply this. This shouldn't really be here because this is more to if you want to create a new field or apply a certain function to this column. So I'm not sure why this is here. There's also transformation. You can look at the documentation for that. It's another feature of group by, where you can get cumulative summation and difference between data sets, which is quite handy. Okay, so all right, so the 2 more things to do is just to look at plotting data briefly. I'll discuss it more next week, but I just want to show you this before we go into merging data frames and joining. So if I did run this already. So what this does is I wanted to do a histogram plot, right? So if you remember this link that I sent or that I showed you, I don't know what I was going to click on it now. From DataViz, that gives you examples of how to close that. That's the one. So, for example, I wanted to just draw a histogram of one numerical variable that I wanted to use. I go to Python, and it gives you a simple example, but you can maybe just a plot like this, right? Comparing 2 features. So all I did is I copied and pasted this data set. Obviously, I'm using the same data set, so it'll look like this. I copied and pasted this and put it in the code. And what this does is it imports a library called Seaborn, which allows you a bit more plotting features. matplotlib as well, which is a default plotting library in Python, and set some parameters. And then I plot it, and I get the plot over here, right? So this is if you just want to visualize certain, aspects of your code and of the data. If you want to know more about this and plotting, you can just let me know as well. So, and the last thing I'm going to focus on now is on combining files and concatenating and merging. So based on a few requests, I'm going to do this in do 2 examples. So hopefully, I don't know why this link's not opening anymore. So if you go to merging, as you can imagine, okay, is this the one? Yeah, there's this is very good documentation on different things you can do with to merge, join, concatenate, and compare. And the different features and the functionality for it. So sometimes the first use case I'm going to use is if I go to my files, if I have, do you want to delete this one? If I have 3 files, if I have 3 CSV files and I want to combine them, right? They have the same column names. There's different data, right? And I want to combine them, right? So how do you do that? That's the first use case I'm going to use. So what I do is, again, there's a few ways to do it, but what I need to do is get the location of the data. So from file list, my file path is specified to where it is. And then I have a for loop that loops through each of the data sets. And then what I'm going to do is I'm going to read in, I have a dummy data frame that's going to, append or concatenate all the data. And then I'm going to read in each new data frame and add, so df temp is my new data frame. I'm going to add it to the empty one. And I'm going to use a .concatenate function. So that just concatenates files and folders, files together that have the same column names. If there are differences, there are ways to do that. But this is, how that works. So if I run this now, if I go back to data, and you'll see later on, I rewrite it to person joined. So you'll see if I go here, there's a new CSV file called person joined, and all the CSV files are now joined together. So a few things that I had to do. I dropped the ID because again, a data frame has its own ID, so I just otherwise be a duplicate. So I just dropped that. So again, if you have lots of files you want to join them together, this is one way to do it. Okay, I'm merging files. So in this case, if we have, let me remove this one. If we have a lot of data, so this is people, the ID, and then the work information, and then another CSV file just with a university, right? How do we merge these, right? So if you're familiar with SQL, you want to merge them based on the ID, right? So how do you do that? So in this case, I'm reading in two data frames. I'm going to do an inner join, and I'm joining it based on ID. And all I do is I say, I'm merging data frame 1 to data frame 2 based on ID. By default, it is inner join, and we can specify left join, right join, and a full join if you know what those terms mean. And then again, I'm just removing this ID because it'd just be a duplicate, and then I'm running it. So if I run that, I get merged, and both CSV files are then merged together. So yeah, so they're merged together, and this is pretty much how you would merge two data frames together. So again, so what is the inner join? So returns only the rows where there's a match on the column name, so ID in that case. You can specify again outer join, left join, and a right join. So I mean, if you are aware of these, then and something that you know how to do, then just you can look at the merge function. Yeah, so I think that's all I wanted to cover for today. So let me just have a look at the questions, and then I'm also going to just get that form as well, so that people can start filling it in. If you have any specific questions or comments, please use the discussion, or I can fill in the form here. Just please start filling in the form, and also again, you can use the discussions. If you have a specific question, something to look at, just under lecture 2, for example, you can add a comment, add your data if you need help with this or with that. So please start filling in that form. Yeah, so let me just have a look. So translate sexy. Yes, so these videos are recorded. Last week's video is already there. The video is already there on NITheCS YouTube. So Jane, if you have a specific questions covering error catching, so I'm not sure what you mean by error catching, but if you have a specific question, put it on the GitHub repo as a comment, and I can try and answer it and cover it next week in the next 2 weeks, because we have only two more lessons left. So if you have a specific question on error catching, because again, in any topic, there are many variables and aspects to cover. So if you have something specific, I can try and cover it in the next few lessons. Can I import all the files into separate data frames using a line of code? That will be difficult. You won't. There are other tools you can use that would they can do that, but most likely not. I can't. Off the top of my head, I can't think of a way you would have to do it. Using a for loop, or there are like built-in libraries like Glob, for example, that can maybe optimize it, but not as far as I know. Can you use merge function with the drop? So once you merge, you can drop whichever column you want. Or Yoga, hopefully that answers your question. So once you merge, you can drop whichever column data you want. I think Quarto is good for reporting, Python as well as R. I don't know about Quarto, Tajudeen. Thank you. I'll have a look at it. Quarto, Python. Have a look at it. And can we get the videos? How can we get output all these graphs, tables to PDF or document or for reports? So Daniel, if you look at last week's video, I did some kind of reporting. If you look at this will be, let me look at the actual folder where I showed pandas profile reporting, which is quite useful. Let me open that up, and then you can have a look. Open with Firefox. So profile reporting is a very nice way to get reporting done on your data. Just a very simple EDA. So that's Daniel. You can look at last week's video, how I did that. How to merge 2 data frames with different column names. Might be difficult to do that. If you have a specific example, I can look at that next week. So again, put that in the GitHub discussion. Why would you use dfmed.drop and not on dfmed CP? So I just copied that. dfmed and dfmed CP was just an extra data frame I created. So I wasn't actually using DataFrame and CP anywhere else. I don't think there are any other questions. Okay, a question on how to download the lecture. So if you go to NITheCS, lecture 2, so here are the lectures. So if you want everything, you just click on, if you want to fork it, which is the best way to do it, you need to have a GitHub account and then click on fork, and then download everything. Otherwise, you can just, click on any of these files and download it, right? So it's publicly available, so you can just copy that to your file, but the best way is to get a GitHub account and just fork everything. So please, that answers your question, Adini. Link to Quarto, thanks for that. Simanga, all the videos are on the on NITheCS YouTube account, so just go there.
And this one will be there by latest tomorrow, yeah.
Yeah. So I think that's it for today. Yep.
Okay. Yeah, then Binjamin, thank you so much. It was another really useful lecture. I learned lots of tricks that I didn't know. Thank you very much. It was really great. And, and you see all the claps and thumbs up. Everybody seems to have enjoyed it very much. So everybody is very grateful for your time and for your effort. And in particular, thank you for putting everything in GitHub. That's really something that we'll have to train all our speakers to do, because that's really the way to go. Yeah, no, thank you so much for that. It's really very nice. And just a reminder, next Wednesday at 2 o'clock, we will be here again for lecture number 3, which will be about data visualization, statistical modeling, and other topics. Yeah. So thank you very much, Binjamin. Thank you very much, everyone, for being so very good followers of this course. We were around 100 today as well, so that's really exceptional. And we had lots of views of the previous lecture on YouTube already.